This is the Raspberry Pi 4B. This is going to be pretty much like the whole brains of the operation here. It's going to store the program, and so on here the user is going to be able to run the script, and then they're going to have the GUI to interact with. And so depending on what they do on the GUI, they're going to make the circuit, and if they were to, for example, finish the circuit will then send the information over to the sensors onto the breadboard. And so depending on what we get there, you can either find a short circuit, or it could simply turn on the LEDs, and it will be then shown on the GUI what happens if you sent the circuit over. So if you had a successful circuit and it was successfully translated, then it's going to tell the user, hey, that's right, otherwise incorrect. And so just to kind of show an example of what the GUI could look like, this isn't the complete version, however, so this is just kind of to show an example of something showing up on the screen. This specific monitor, actually, this is a 5-inch monitor by Elecro, and it is touchscreen as well. But just to give an example of something working, if we click on Add Component, it might be kind of tough to see on a video. I'm just going to click it a bunch of times. And then let's just back out here. Oops, let me run down here one more time. So you just click on Add Component a bunch of times. You can see it shows up. And so we have a successful GUI, although not complete right now, but we have a GUI that can work and the user can interact with, even on touchscreen if they want to move components. Yep.
3. So this right here is the advanced breadboard. The topic I'm going to be discussing is the variable power supply for the user circuit, as well as the user's load and the voltage and current sensor. So we have this power supply over here, imitating the user's variable power supply. We have it at 2 volts and 20 milliamps. So this would go all the way to the current sensor, which is right here. And from the current sensor, it will also connect to the user's circuit. So for this plain circuit, we have an LED, just to show an example. So the LED is receiving 2 volts and 20 milliamps. And then from there, the sensor will also connect to the MSP430 using the SL and CDA pins for the I2C. So this would connect to pins 1.6 and 1.7, and that's how we'll transmit the data from the power supply and the load all the way over to the MSP430.
So here we have an example of how our LEDs are most likely going to be on the breadboard. So we need the LEDs to show the user which nodes need to be occupied. See here we have a 100 ohm resistor, and we need that because the LED requires 20 milliamps of current, and the MSP430 is getting a little more than that. So as here, the code is already on here on the MSP430, which basically just turns on the LED when activated. Right now we don't have it turning off just because that's kind of a default. We have this powered rather than through, typically it's powered through the USB, through the computer, but in here we wanted to simulate what our voltage regulator would be doing, so we have that on the ground in the voltage supply. So we can follow that up here to what is, kind of our temporary voltage regulator, and this is kind of how it would be set up.